is a constant. A is a constant. You're not in multivariable calculus or in single variable calculus, so you're going to have x and y at the most. So you have to implicitly differentiate this. So can someone tell me what the first implicit differentiation is? Someone raise their hand and tell me. Maddie, what is it? I'll start you off. 4x cubed plus times what? Y prime equals 0. Exactly. Very good.
So y prime is going to be...
Well, okay, hold on. We could isolate y prime at this point. We don't need to. We don't need to isolate y prime at this point because we're not done yet. We're trying to find y double prime, right?
Can you isolate y prime?
You could. Let's do this here. So if we wanted to, y prime is going to be equal to negative x cubed over y cubed. The 4's cancel. Okay, we can do that. That's fine. At this point, what do we need to do? We need to find second derivative. We don't need to isolate y prime in order to find it, though. You can do this, and you end up with x cubed plus y cubed y prime equals 0.
Mm-hmm.
Why do I prefer to do this next derivative there instead of here? What am I avoiding?
Quotient rule.
I don't like the quotient rule, so by default, I try to dodge it if I can. So if we do, let's do it both ways, we should end up with the same thing.
My question real quick is, could you also turn y cubed into y negative 3? Y to the negative 3?
Yes, you could. Absolutely. Absolutely. Sure. So are there many different paths? Absolutely. And that's another way to dodge it. For me, I would just do this and go, I'll keep going. I wouldn't even isolate y prime yet.
Yeah.
That's just, you will later need that information, but you don't need it yet. So if we do this out here, we take the derivative again. Can someone tell me what it is? 3x squared. So the derivative of the first times the second plus the first times the derivative of the second. Thank you. Thank you. 3y squared. Yes. Does everybody see what I did there? What did I use on this? Product rule. The first function is y cubed. What's the derivative of y cubed? 3y squared y prime times prime because it was already there, plus the first y cubed times the derivative of the second, which is y double prime. What do we need to isolate now?
Y double prime.
Yeah, so let's clean this up a little bit. You have 3x squared plus 3y squared times y prime squared plus y cubed y double prime equals 0. What does y prime equal?
That.
Keep that in mind. Let's isolate this first. So what do we end up with? We end up with y cubed y double prime is equal to negative 3 times x squared minus y squared y prime squared. I just subtracted these two things and factored out the 3. Now what do I divide by?
Y cubed.
So end up with negative 3 times x squared minus y squared y prime. Do you notice how I'm putting that parenthesis around there? I want to be very clear that that's y prime squared divided by y cubed. Now here's the thing. That is not in terms of x and y. That's in terms of x, y, and y prime. You need to, at this point, do what? You have to take this and plug it in right there. You have to. You will do this. So y prime, double prime is going to be equal to negative 3 times x squared minus y squared times negative x cubed over y cubed squared all over y cubed. Now, could we clean this up a little bit?
Yep.
You could. Is this the derivative? Yeah. That would show me that you did everything you needed to. That would show it very clearly because what does this show you did? It shows you implicitly differentiated twice and you substituted at the end. You'll be forced to do that because sometimes they'll ask you to evaluate the second derivative, and if you don't substitute it in the first derivative of y, it's going to be a problem. But you're going to think to yourself, oh, I need y prime at this certain point. So you can go back and evaluate it first and then plug it in. But if you want an expression for y double prime, you'll have to sub it back in. On a multiple choice test, are they going to write it in terms of y prime? Probably not. They're going to write it in terms of x and y. Does that answer your question, Tina? Yeah. So be careful. It's a quadratic. Thank you. This is a quadratic. So, Bissell, what's the general form of a quadratic? F of x is equal to what?
Quadratic.
Yeah. Ax squared plus bx plus c. So that represents any second degree polynomial. And what does it tell you? P of 2 is 5. So when you plug in 2 for x, what do you get out? So therefore you know that 5 is equal to 4a plus 2b plus c. I plugged in 2 for x. What is 2 squared? So it's 4a plus 2b plus c. Okay, so to answer this question, we need a value for a, we need a value for B, and we need a value for
C.
We have one equation, we better find two more. P prime of 2 is 3. So what is the derivative of this function? What's f prime? 2ax plus b. And we know that 3 is equal to 2a times 2 plus b. So what do we know? 3 is equal to 4a plus b. So we have one equation, a second equation, but now what does it say? It says p double prime of 2 is... What's f double prime, Tina? If this is f prime, what's f double prime?
It is x.
This is a constant.
Oh, I'm sorry. 2a.
2a, yeah. 2a. And what does it say to you? It says that f double prime of 2 is 2. So 2 is equal to 2a. Ah, so what now can you get? What's a equal?
1.
1. You plug it in up here and you end up with 3 equals 4 plus b. What's b equal to? -1. So now you take both of these things and do what? Plug it into there, and you end up with 5 is equal to 4 times 1 plus 2 times -1 plus c. So what is, you get 5 is equal to 2 plus c, so c is equal to 3. So to answer this question, the answer to this question is f of x is equal to x squared minus x plus what? 3. There it is. If you keep on going, I mean, the nasty thing about it, could this theoretically have, is this a pretty straightforward substitution problem? Yeah, with b equals -1. Would I expect you to be able to solve a substitution with 3 variables? Yeah, I would. I would expect you to. Okay, it's basically finding a function. N will be in your answer. So I don't like the quotient rule, so what am I going to do to this, Fitz?
Turn it into 3x.
To the
Negative
3x cubed to the,
negative 3.
nope, 3x cubed to the what?
-1.
-1. So this would be equal to 3 to the -1 times x to the -3. That's one way to write it, right? Are we okay with this? I'm going to keep it like that. So let's make a table here. So we have the function and the n value. Okay, so if n is 1, that's the first derivative. So what's f prime going to be? F prime of x will be what? Negative 3x cubed to the -2 times what? Times what? 9x squared, yes. Do you agree with that, everybody? Can we clean that up? Yes, please clean that up. What's that going to be equal to? It's going to be -9x squared over what? 9x to the what power? To the 6. So what's that equal? -1 over x to the what? To the 4th. So what's that equal to? Do you agree with that?
Oh, negative.
Negative x. It doesn't.
Negative x to the -4. Does that work? Did we do the algebra correct?
Yes.
We dropped the -1 to the front right there. We made that power 1 less. And then what rule are we using when it kicks out that 9x squared? The chain rule. The derivative of 3x cubed is 9x squared. This gets dropped to the bottom and squared, so it's going to be 9x to the 6th because you multiply the 3 and the 2 to get 6. The 9's cancel. The 2 power and the 6 turn to 4 in the denominator, so it's -x to -4. Okay, that's great. So we now know that this corresponds to this. When n is 1, there it is. So what do we need to find next? When n is 2. So let's find the second derivative. So that's the first derivative. Can someone tell me what the second derivative is? Someone new hasn't spoken yet today. Corey, what's the derivative of this right here?
Would be 4
X to the what?
-5.
-5. Correct. Yeah. No, because the -4 drops to the front and there's already a negative there.
Oh.
So it's gone, right? Okay, so that's 2. What about f triple prime here? This'll, what is it? The derivative.
-20 x to -6.
That's what? 3. I'm not going to multiply it out because it'll help you see the pattern. What's the fourth derivative, Tony? 4 times -5 times what? You agree with that? Let's do f5 of x. Sam.
4, -6, -7,
Yep, times x to the.
-8.
So this is the. That was
That's
the
the fifth.
fourth one. This is the
Fifth.
fifth one. So what we're trying to find is, what is fn of x going to be? First of all, let's ask this question. What's happening to the sign?
Still changing every other.
It's positive, it's negative, it's positive, it's
Negative.
negative, right? So you know, therefore, there's going to be a negative one to some power, right? 5 is negative, 4 is positive, so it's going to be to the nth power, because negative 1 to the odd power is negative. Negative 1 to an even power is positive. So that takes care of the sign. What about this thing right in front here?
Factorial.
So it's 5 goes to 7, 4 starts at 6, 3 starts at 5, 2 starts at 4. What's the relationship between 2, 4, 3, 5, 4, 6, 5, 7? 1 greater, right? Do you agree with that?
Or less.
So it's factorial.
It's n plus, nope, 5 to 7 is
Oh, two.
2 factorial, but what's missing? Is it the complete factorial? Does it go all the way 3, 2, 1, 3, 2, 1?
No.
No. So what do you have to divide by? Okay, 5 factorial is 5 times 4 times 3 times 2 times 1, right? But you don't want these, so what do you have to divide it by? 6. You need to divide it by what? 6. Divide it by 6 because you're cutting off 3 times 2 times 1. Okay, and what power is it? X to the what? 5 to -8, 4 to -7, 3 to -6, 2 to -5. Negative n minus what? 3. -5 minus 3 is? -4 minus 3 is? There it is, right there. There's the nth one, because if we wanted the nth term, that's what we could plug it into. This is the explicit formula, because all you need is what? All you need is n. The implicit one would be you need all the ones before it. So if I wanted the millionth one, could you plug in a million and get an answer? Yeah, it'd be very, very big, but can you get it without computing all the ones before it? Yes.
What's the exclamation point?
Factorial. 5 factorial is 5 times 4 times 3 times 2 times 1. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Are we good? Yes.
Is this specific to just the function we did, or is it work for anything?
Which? This formula? It's totally to each one of, that's why they asked different ones here. So ready? Let's do another one.
One more thing. How does dividing by 6 get rid of having used 3 and 2 and 1?
Because, let's try this. Ready? 6 factorial over 6. That's 6 times 5 times 4 times 3 times 2 times 1. All over, what is 6? 3 times 2 times 1. What cancels? 3s, 2s, and 1s.
Oh, that you also do the factorial to this.
You do the factorial to the bottom of this.
Okay.
Well, 6 is 3 factorial. 3 times 2 times 1.
Right. Okay.
So we wanna-
I thought you were just dividing by 6 after it's factored.
Oh, I'm by 6 after the fact, but
That's
6
still
is
the same.
3 times 2 times 1.
Oh, okay.
6 is 3. So I'm right instead of writing 3 factorial. So, ready? I want you guys to do, these are great questions. See if you see a pattern. There will be a pattern, and you need to describe it just with n. Record. You got, what is it?
2n times e to the
Times-
2 to the n, sorry.
2 to the n times what?
Times e to the 2x.
Yeah, every time you take the derivative, what's going to happen? You're just going to drop a 2 down. Just going to keep on dropping a 2, keep on dropping a 2, keep on dropping a 2. Boom. What about this one right here? Who has 34? Anybody get 34? Bill, what do you have?
I have prime n I equals -1 to the n squared.
-1 to the what?
N squared. Yeah.
To the n?
To the n and
Oh, actually, hold on. Let me fix something first here. Hold on. I need to, this is not proper notation. I need to write f of n, x, right? Times what?
times n factorial.
Times what?
N factorial.
N factorial. Okay, yep.
Times 5x minus 1 to the negative n minus 1.
Negative n what?
Times 5 to the n.
Taking out a 5 every time, too. Yeah, good job. Times what?
5 to the n.
So I'll put this so it's clean. 5 to the n. Looks right. So homework, part of it, understand that. / verify that. That looks good. That looks good. Okay, ready to move on? Definition I want you to go with is y equals log base a of x if and only if. If and only if. That's what that double arrow means. If and only if. If and only if a to the y is equal to x. You must remember that. You must remember that. Okay, so let's talk about this. What do we have here? We want to find the derivative of y equals f of x. Y equals log base a of x. The first thing we're going to do is take it and go from its log form. Here is the log form. And we're translating that into what? The exponential form. Okay, so we have it in exponential form. Now we're going to differentiate, but we have to differentiate implicitly. Because y is in the power. We have to differentiate implicitly. So what's the derivative of a to the y? ln a to the y times what? Y prime equals, hey, what's the derivative of x with respect to x? 1. So can we isolate y prime? Yep. Y prime is equal to 1 over ln a times what? A to the y. What is a to the y? So we end up with 1 over x ln a. So if y is equal to log base a of x, the derivative is 1 over x ln a. What a value do we really like? 1 is actually okay. Sorry, 1 is okay. We like e, too. What is the derivative of ln x? If y is equal to ln x, what is y prime equal to? 1 over x ln e. But what is ln e? 1 over x. So the derivative of ln x is 1 over x. This is really super important. What's the derivative of, let's say y is equal to log base 6 of x? What's y prime? 1 over x ln what? 6. Exactly. Don't forget that. You tend to do the derivative of ln so frequently that when you get the derivative of log base 6, for example, you forget that ln 6. Don't forget that. That's really important that you don't forget that. We're composing sin x into ln. So what's the derivative going to be? 1 over x
Sin x.
sin x ln
Ln e.
ln what?
E.
Ln e
Yes.
times what?
Times cosine x.
Cosine x. Does that clean up rather nicely? What's ln e?
1.
1. What's cosine over sine?
Cotangent.
Pretty cool, huh? Why is it ln e?
Because it's log base e.
It's log base e. This is really important. I see that all the time. You'll see sine x times ln of sine. No, what's the base? E. You like ln that way. Okay, what about this one here? Yes? Because we're not taking the derivative of natural log of x. We're taking the natural log of sine x. So we have to use the chain rule. What's the derivative of the inside? The derivative of sine is cosine. That's why. Don't forget all the other rules that still apply. So what about this one? What's the we've composed two functions. What's the outer function there? Square root. It's literally on the outside of it, right? So in this case, what's so that was the derivative. If we differentiate it, what's this going to be? 1/2 ln x to the negative 1/2 times
1 over x.
1 over x. Done. That's it. What about this one? If we differentiate this, it's going to be 1 over 2 plus sine x. That's x in this case.
Ln 10
ln of 10 times what?
times cosine x.
Cosine x. Yeah. Chain rule still applies. Chain rule still applies. Now, what about this right here? Do I like the quotient rule?
No.
No. What can you remember? Please remember this. Oh man, I'll be so happy. It's there. Find it.
Chain.
Right. Division is division of logs. This is fun on the recording. When you divide, what can you can expand it? What? Subtract. Right. So this is the same as d over dx of ln of minus ln of minus 2. Thank you. Yeah. Okay. Can we clean this up a little bit even? Yeah. So this is the same thing as d over dx of the first one, ln of x plus 1, minus what? The derivative of d over dx of root. What can you do with that square root? 1/2 power, and it turns into the coefficient. Who taught you about logarithms, Maddie? Wow, I walked myself into that question.
Yeah.
But she was doing so well. Well, it's good that she's doing well about the logarithms. I guess it's irrelevant who you learned it from, I guess. That's nice because we don't have to, we clean that, we flatten that out. So if we do the derivative here, what's the derivative of ln of x plus 1?
It's 1 over x plus 1.
Yeah, times ln e. 1 over x plus 1 minus 1/2 of ln of,
X.
no, 1 over, sorry.
1 over x minus 2.
Done. Did we have to use the quotient rule?
No.
No.
Do we like that?
Wait, what?
Yes.
等一下，什么？
How do you get the
From here to here?
no?
Yeah. Right?
Oh,
Yeah. Oh. Log of x to the n is equal to n times log of x. Square root is 1/2. So we just avoided using the chain rule. Is that nice? It is. So can you flatten these things out? Yeah, you sure can. Now it is. Okay, so here's this. Could you theoretically differentiate that right now if I asked you to?
Yes.
You would have to use, you can't really simplify it, so what's the overall rule you'd be using, the outer rule? Quotient, but inside the quotient you'd have to use the
Chain.
and product. You'd have to use the quotient, product, and chain rule. You could do that. Is it going to get kind of...
Yes.
Sure. Could you do that? Yeah.
Very much so.
Golden rule of algebra that you like to subscribe to is if you do the same thing to both sides, generally speaking, is that okay?
Yeah.
You still have a true statement. Do you agree with that?
Yeah.
If I add 5 to one side, I could add 5 to the other.
Yeah.
Remember that random adding and subtracting thing they did inside the proving the inverse sine derivatives? Remember that? It's like adding something so you could factor it. You're adding and subtracting the same thing. That's the same thing as adding something to both sides. The balance is still there. That is generally true. Am I allowed to, now here's a log rule for you. Do you remember this? If log A equals log B, then what? Do you remember that?
Yeah.
And that vice versa is true. If A equals B, then log of A equals log of B. Same base. Are you okay with that? If I wanted to, could I do this? Could I just put an ln in front of both sides?
Yeah.
Do you agree with that? Is that okay? Am I allowed to do that? Yes. Okay, so if I have division in log ln, what does that turn into? So we have ln y is equal to ln of x to the 3/4 times the square root of x squared plus 1 minus what?
The derivative.
No, ln of
3x.
3x plus 2 to the... What can I do with powers with logarithms?
Coefficient.
And what does multiplication mean? The powers add, yes, but in logarithm it just means adding. Right. So in this case you have ln, and that's not an L or an N. H. Well, I guess it's what you get if you combine them. So you get ln of x to the 3/4 plus ln of the square root of 3, it's x squared plus what? Thank you. Minus 5 ln of, we're not quite done yet. What can you do with powers? ln y is equal to 3/4 ln of plus 1/2 ln of minus the same thing here. Now, have we done any calculus yet?
No.
No. We've done what's commonly in Algebra 2, but we put in pre-calculus. We've just used basic logarithm rules. Now, here's the thing. Can we take the derivative of everything? With respect to x. Yeah, absolutely. What's the here's the key to it all. What's the derivative of ln y with respect to x?
1
1 over y.
Y prime.
Yes. Yes. because y is a function of x. You're actually using the chain rule. So that's 1 over y times ln e, which is 1 times y prime. What's the derivative of that right there?
Over x.
Yeah, well, 3/4 times
1 over x.
1 over x plus 1/2 times
1 over
x squared plus 1 times what?
That's
2x minus 5 times 1 over times 3. Exactly. Can we clean this up a little bit? You don't have to go berserk with the cleanup, but let's combine what we know. We know that therefore y prime is equal to y times 3 over 4x plus x over what? X squared plus 1. You see the 2's cancel there? Minus what? 15 over 3x plus 2. Are we almost done? What does y equal?
the original equation.
Yeah, ready? Ooh. Y is equal to this, right?
Yeah.
Correct? So I'm going to take that. I'm going to put it right here. Move it right up here. That's y, right? And then you just take this. It's the same thing, right? Times this. And there's y prime. Did you just differentiate it?
Yeah.
Yeah, you did. Is that a heck of a lot nicer than using... It looks kind of nasty, but did we have to use the quotient rule?
No.
Product rule?
No.
Not we kind of had to use the chain rule, right? That's about it. If you use basic log rules, can you come up with something? Is that, compared to how ugly it could be, is that really clean?
Yeah.
That is ridiculously nice compared to how it could be.
Can I do a second derivative?
No. I do not want to. You could. You could you could take the log of both sides. Wow, that's a new one. This is called. We just learned, everybody. I just want to give you what this is called. This is called logarithmic differentiation. Logarithmic differentiation. Logarithmic differentiation. Yeah, that's a new one. We'll call it the Bill Jang method. It's like, find the second derivative using logarithmic differentiation of bleh. The reason I don't like giving that, I only give one of these in most of the tests, is because are there lots of different ways to do this and come up with something that's correct but written differently? Yeah. Hopefully you'll leave it. We could. Why do we use natural log?
Because it cancels out. It's nice.
It plays nice with taking the derivative of a log, right? So you could arbitrarily choose like log base pi. Like you'd have to keep on writing that. Not cool. I have a question for you. In your book, base 10 is also commonly used, right? Because
Yeah.
the invisible base is 10. Why do some books use ln a whole lot more than they use log base 10? I mean, theoretically, could we do the same exact thing with log base 10?
Yeah.
Absolutely. And it would. Why ln instead of log base 10?
And you don't have to multiply by the extra term.
In this case, you don't have to multiply by the extra term. But let's just say it's just a matter of writing log as opposed to ln. What's the only difference?
It's one letter.
I think definitively that if you're writing a huge log problem, you have to do it like 100 times, would you choose ln? Yeah, you would. And I think it really comes down to that. I think ln is being used way more in certain circumstances because it's one less letter. That's right. Mathematicians have good reasons for doing things. Or not. Okay. So how about... Let me pick one of these. Which one do I want you to do? Ooh, that's a good one.
That's not.
How about you try all 4 of these? You do them because some of you are going to fly through these and some of you it takes a lot longer, okay? I want you to do this one.
I like.
You know what? That's a good... This is a good order. Do them in this order. This will be a good lead-in, yeah. Do them in that order. And you're using logarithmic differentiation. Y is equal to that thing. So you end up with y prime is equal to 2x plus 1 to the 5th times 4th minus 3 to the 6th times this. What about here? What about this second one? What do you need to know cold?
The derivatives of
Trig functions. The derivatives of the trig functions. You must know them, you must know them, you must know them, you must know them, you must know them. Clear enough? So First thing you have to do is you have to flatten this out. You take the natural log and you flatten it out. It's going to turn into ln of y is equal to 2 ln sine x plus 2 ln tangent x minus what? 2 ln of x squared plus 1. If you fully flatten it out, you don't have to deal with the squares.
No.
Can you finish that for me if you needed to?
Yeah.
Yeah. Flatten it out. Finish it. Okay. So let's actually talk about one that is a little trickier. Let's talk about this last one right here. That looks really crazy. Find y prime if x to the y equals y to the x. That looks totally weird, right? What do you have to do first? It's the same step. What do you do to both sides?
I would assume take the natural.
Yeah, so you have ln of x to the y equals ln of, what can you do with exponents?
You drop them.
Y ln x equals x ln y. You've now flattened it. There's nothing else we can do to flatten that any further. Now what do? You take the,
Derivative.
what do you have to use on both sides? Product rule. Very good. You have to use the product rule. The derivative of the first is, on the left, y prime ln x plus y, what's the derivative of ln x? 1 over x equals the derivative of the first times the second plus the first times 1 over y times what?
Y prime.
Y prime. What do we isolate now? So we have y prime ln x minus x over y prime, right? X over y. I'm trying to keep the y prime separate. Equals ln y minus y over x. We okay with that? Is that okay so far? Can you just make sure I don't make an algebra mistake? So in this case, y prime is going to be ln y minus y over x all over what? Minus x over y. Is that entirely in terms of x and y? Yeah, you just did it. If you take the natural flatten correctly and use the basic derivative rules, you should be okay. What types of errors are most common on these logarithmic differentiation question? Algebra, by far. Your algebra is by far the most common errors. Absolutely. Absolutely. No, you guys are okay. Let's do this last one because we have the time. We'll do the last one here.
The higher your math skills get, the worse your
No. It's confidence level. You guys you just use it. You're fine. You're fine. You don't have confidence? You have confidence.
That's like
What did you do first?
natural log.
Yeah. ln y is equal to x ln x. So y prime over y is equal to 1 times ln x plus x times 1 over x. What's the derivative of x? Uno. What's the derivative of ln x? Derivative with respect to x, yep. So do we actually have this here? Yeah, y prime is equal to y times ln x plus what? 1. And what's y equal to? X to the x times ln x plus 1. All done. No trick to that.
Yay.
All done. So I'm kind of satisfying because it really feels like you're doing a whole. You are.
I like
As long as you're consistent, it's a great way to practice your product, power, chain rules, flattening things out. You must remember your basic log rules, though. Here's one thing that we might run into that I just want to ask you about. What does this equal? Log of a plus b? What does that equal?
Log A, log B.
No, nothing.
No. If you multiply inside the logarithm, that's adding outside. But adding inside the logarithm there's no go from. There's nowhere to go, okay? You have to do whatever you're going to do right there. You can't, there's no cute thing you can do. Okay? What about log a minus b?
Nope.
No.